Thank you. This is the first time that we are speaking to an event like this, so maybe we'll be a bit cluttering in our talk, but I hope you will bear with us. We are going to talk about building desktop application using Electron. And because it's an Angular2 event, we will also be talking a little bit about that, because we built the application using Angular2, of course. Just a little bit about us. This is my colleague Chris, and I'm Lars. And we work at a small company called Invokers. I think we are maybe 20 people all in all, or something like that, so we are fairly small. But we primarily build software around SAP. And louder. Oh, sorry. Yeah, we primarily build applications around SAP, which is a huge German enterprise system. And in the later years, many of our customers also want nice user experiences. So we have been building that for a time now, mainly in JavaScript, with all the regular stuff that most of you probably know already. Today we will be talking a little bit about what Electron is, and why did we choose it in our case. Maybe I should just say that the thing I'm going to talk about, or we are going to talk about today, is a customer case. So we built an application using Electron with Angular2, and it's running in production right now. I think there's how many deployments right now?
We have like 150 clients deployed right now across 25 stores.
Yes. I will also be doing some fairly short demos just to show how easy it is to get going with the framework. And in the end, Chris will be talking about the real-life cases that he has been working on. I'm sorry. Does everyone know what Electron is? No? Some of you? Have some of you also been using it? There's a few hands. Well, just introductory. If you know the Atom editor, which is built by GitHub, it's the first editor, I think, or the first product built with this framework, and GitHub actually released it together with the editor. So they built the complete framework and released it when they released the editor. And I think some of you may have heard it named Atom Shell, which was the initial naming of it. And yes, it's cross-platform for desktop applications with JavaScript, HTML, and CSS, so all the regular stuff. Underneath, what it does, it takes the rendering engine from the Chromium project. So you actually have access to the same rendering engine that you have in Chrome. And then the backend is Node.js, so the whole backend part of the framework is Node, so you have access to all of the NPM packages, and everything you have in Node, you have in Electron too. Furthermore, you get from the framework the ability to package your app for all three major platforms, Windows, Mac, and Linux. Also, you get, because of its native ability, you get the native menus, dialogues, and notifications, and so on. And they are native to the operating system, so if you use a notification, it will be the native to Windows and to OS X and to whatever other. Furthermore, you get the automatic updates, so you can set the application to update it. If you know some of the applications already, like Atom, you get the ability to auto-update it. You get that delivered from the framework out of the box. So why did we choose it? Well, we had a customer with an existing desktop application. Just a few words about our customer is they are selling textiles, clothing, and so on in the stores. And right now they are having these cutting tables where they sell a given amount of product. Right now they have existing desktop application, or they had, now they are running with this new one. They had existing desktop applications and they want a replacement for that. This also included some changing in the infrastructure in the backend systems. To the machines, it's a regular desktop machine out there with a ZPL printer, barcode printer, and a scanner, barcode scanner connected to the machine. So we needed the native access. We also needed the ability to function with no network access. Sometimes they lose the access for some other reasons. And they also wanted the easy deployment. Yeah. Whoop, whoop. Sorry about that. Yeah. One of the reasons that we want to use that framework is that it's a very stable framework. There's a lot of application being built on the framework at the moment. I think most of you know Slack or Visual Studio Code. I saw the other guy using it already, so that's also built with the framework. And it has a huge and very active community. So a lot of new function is appearing all the time because of this community. And as I said before, there's a lot of quality apps already out there. All right. I'll just do a quick demo, a couple of demos. The first one is just the Quickstart application directly cloned from the GitHub repository. And it's pretty straightforward. Initially, we need the Electron binary, which you can install through NPM beforehand. But otherwise, you're good to go if you have Node already. So I think most of you have that. When you clone that application, what you get is an HTML file, an index HTML file, a main.js file, a package.json file, which is the regular, and the render.js file. Everything happens in the main.js file, or at least to kick it off from the beginning. So in this case, we just require the Electron module, using the app module. We also have a browser window and some other useful stuff here. In this case, we just create a browser window with these width and height. And we tell here to load the specific file in this library. And in this case, we also want the dev tools to be loaded when we start it up. And on the app module, we connect to the ready event and create the window. And when everything closes, we quit it. And yeah, when we activate on OS X, we recreate the window. That's basically it. Whenever we need DOM access, we have a renderer process for that. And the renderer.js file is used for that. And it's required here in a script tag. But let's go ahead and just kick it off. Yes. And then you actually have complete application running. We have the Electron menu up here with the native. And then we are running Node.js, a new version, and the Chromium version. And yeah. Also we have because it's a Chrome render, we have the dev tools. Yeah. So it's pretty straightforward. This was just a simple example. So I also want to show how easy it is to actually do something with the native access we have from the framework. And I have another example for that, with just a bit more. It's pretty much the same as before, but in this case, we have a button with an ID, and this basically the same as a regular web page. In this case, we connect from our renderer to the button and create a notification. And this just uses the native, the framework handles the native integration in this case. So this is actually everything we have to do. Also, this application has a tray. It has access to the dock, and we have the menu defined here. So to use the tray, this is actually everything we need. We require the app and the menu and the tray using a path, and yeah, just go ahead and do all that. And we have a dock integration. And in this case, on the OS X thing, we will see the updated dock menu down here. I think maybe it's hard to see. And we have a menu. Yep. And we have the tray we saw before. Connect this shit here. And we have this menu, and we also have the dock. So that is delivered and catching events here. And of course the native integration with the notification center. There's all sorts of things you can do with the API. All right. As I said before, we have two kind of processes. We have the main process, which is pretty much as a main rendering or a main UI or main process where you do a lot of the integration with the native system. But if you want to do background tasks, for example, And other things, you have to do it in the render process. Also, if you have to have access or need access to the DOM, you do it from the render process. And this small image does a pretty good overview of what you do in each of the processes. You handle the browser window and the menu and also power monitor and all that. And you have to communicate between those processes through the IPC, which you have a IPC main, and you have a IPC render where you can do inter-process communication through that. This means you can do a lot of async communications if that's what you need. So yeah. I just want to show the Angular application of it. When we started the project, we made a boilerplate application for that. And this is the outcome. It's a basic Angular application, but created before the CLI was available. And we are using TypeScript. So this is basically it. We have the package JSON with all the requirements, the TypeScript config and the TSLint and all that. And here's the same as, can't see that. Yeah. We have the index page, and in this case we load the app and the other requirements. We have the main.js, which is the same as before, even though it's an Angular application. And then we have the app, and this is where everything happens. So let's go ahead and start it up. I don't know if hope it will. Yep. And here it is. It's very nice. Huh? But in this case, we have the tray integration too. And just a quick note on how that is made. It's a tray module, and in this case, it's just a service. Pretty much the same as before, but with the native TypeScript typings too. And it's loaded here. So it's pretty straightforward to use if you have an Angular app already running. So yeah. Yep. There's also sorts of nice scaffolding tools if you use one of the other nice frameworks out there. React Desktop, which is primarily pointed at making desktop applications in React, and there's also the Vue, which is gaining a lot of popularity at the moment, I think, and of course there's a lot more. Yeah. So now my colleague will present a little bit about the real-life case, so we will just have to switch our mics.
Okay, so in the real-life case, like Lars said, we dealt with a textile business. Unfortunately, we are not allowed to show the actual program, but yeah, intellectual property and whatnot. So, but the program is actually just one input field and a button to get whatever needs to be printed. So instead of that, I'm going to walk you through what it takes to get this Electron app deployed. Like your usual Angular app, you have your package.json to handle all your node package management related stuff. With our Electron app, you split that out in two package.json files. So you have your root folder, which holds the package.json file for all your development dependencies. These are the things that we do not want to distribute out to all our clients' machines hooking up to the release server. So, and then you have your app folder where you keep all your normal dependencies for your application. This is Angular and Core.js and what else you need to get your app actually running. This is the recommended way to do it, because if you include all your development dependencies, you're going to need 300 megabytes or something at least for deploying updates. And this way you take out all those unnecessary files. When you split this out, you need to package your application before you release it on the server. And there's a really simple tool for that. That's Electron Builder. To package your Windows application, this is the command you run. It's build --win. It creates the distributables for that you need to upload to your server. So that includes an executable and a NuGet package. The executable is the asset that the user can download to get the latest version. And the NuGet package is the one that's deployed for auto update. So, and I'm going to show you a little bit about this, how we hook Electron up to the release server 2. Our app it's mainly a Windows application. They use really old hardware in these stores. So we are talking about Windows 32-bit. And the Electron release server, it has some problems with the Windows release. So if you're going to do this, you need to decide to either run only 32-bit or 64-bit, because the team behind Squirrel and the Electron release server have already said that they will not fix this bug. And if you're running on a Windows 32-bit and you deploy the 64-bit assets on the server, it will start getting the 64-bit versions for your machine. And they, like I said, they won't fix it, so no use trying. Or you could use 2 different servers for it if you really need it. The Electron release server, it's a really, really simple server. It took like half an hour to set up for our production environment. It has an Angular.js app running, which is easily customizable if you need that. It just have a download page, and then it has a simple administration area where you can upload your assets, and that's basically it. Everything else is just the Squirrel Framework running in the background. I don't know, does anybody have any experience with this? Show of hand? Okay, 0. So the Squirrel Framework is it's a click once installment framework. So if you package your file in this framework, you get an executable, and when you double click this on Windows, it just installs. There's no user interaction. If you use Atom or Visual Code, you would probably see this. It just quits and installs the update when we deploy it. It's really simple because it cuts down. We really cut a lot of support hours for our client doing this, because their old software, if they needed to push updates for this, the users got a confirm box in the software, and they usually call support. And they haven't had one call since we deployed this. So that's actually a pretty good success story. So Anyway, Squirrel. I'm going to show you a little bit code here. Okay, so first, let me just, that's, okay, yeah. In our main JS files that Lars was talking about, we include 2 lines at the top. The Electron Squirrel startup, it is basically the library you get from the Squirrel Framework. You include that, like I did here, and it will do some magic. So you don't really need to do anything here. And then we have the handle Squirrel event. This is called after your application quit, after it gets the auto update event. I can show you this now. So the auto update event, it's actually just one method. If you use Angular, you can do it like this. It's just an event handler. It quits and installs the application after checking for updates. If it receives an update and this download happens automatic with this function call. So when the file is downloaded, it quits and installs. And Lars talked a little bit about the IPC and main processes, and this auto updater is also calling the main process in Electron. So, yeah. Okay, back to the main file. After it quits and installs, it goes into this function we have down here, the handle Squirrel event. This code on top is just wrapper code and setup of variables. So the easy part, like I said, this is really simple. So you have these calls. The Squirrel install, that's when you just get the executable and the user installs it first time. So, and what happens below here is what you want to do. We only need to create the shortcut. This includes creating it on the desktop and installing it in your start menu for Windows. And when that is done, it just quits after a second. It's the same for updates. We don't really need anything else for this, so it just quits after it's updated. And then you have the uninstall case where, well, it's just the reverse of the install. So when they uninstall from add and remove programs in Windows, this is what's called. And the obsolete thing, that's when we receive an auto update, the obsolete command is called for the outgoing version. So if you need to migrate anything on a local database or what else, then you will do this here, and then this is run before it updates to the new version of the application. And that's basically it. When you have your server running, this is all you need to include in your program to have auto update. And for your Electron app or Angular application, you can place this check for updates wherever you want. So if you want to create a dialog to check for updates, then you can do that. We just do it when the first time the application starts, because they start it every morning when the store opens and it's running all day. So if there's an update, we only do it early in the day. Then when we deploy it, we have a couple of test stores. So if something really goes wrong, we have like 20 hours or something to handle this. So that's that's our deployment. So we have our let's see here. Okay. So our application, it's an Angular application, and actually I talked a little more about the deployment here because the example I've brought is very much similar to what Søren just gave a speak about. It's not Redux, but it's about state management in our application. So what we have here is we have our main app component, and then we just called it a state service. But this basically or handle what Søren was talking about. I mean, he talked about actions. This handles actions between our service layer at top and all our subcomponents on the bottom. So the main interface for this application, it's a little bit different than if you're used to working with web development, where you mainly use the mouse. We have a keyboard, and then we have a barcode scanner. The barcode scanner, if you haven't worked with this before, it's basically a keyboard. So when they scan a barcode, you receive these events from, like keystrokes from a keyboard. So it's easy to handle. Yeah, so our service layer, it has more services than this, but we have some global services, like the scanning service that runs in the main component, listening for events. Because depending on what subcomponent is active, when you scan, we always want to go to the screen you want to go to when you scan. So it's global, and it navigates GApp whenever it receives a valid scan. It's the same with shortcuts. That's propagated down from the main component. It catches events from the main app component, and then it sends out the state, and it will switch and navigate the app depending on what shortcuts you push. Electron has a shortcut library if you need it. We just needed something really simple, like we use the function keys and the control and alt keys. So we made a pretty simple library for it ourselves. In the background, we have another global service running. That's the synchronization. It downloads all the data from the headquarters a couple of times a day or something, in case they go offline. So we have a file-based database running on this because one of the main points of this application was they have a server in each store, and one of the main points was to get this server out of the store. They don't want to spend money on power for it, and actually when this is all said and done, the power over 2 years for these servers is close to the budget for this application. So it's pretty, yeah, they're pretty satisfied with it. So, and then we have the print, like Lars said, that's CPL. Have anybody tried working with that? Okay, so that's your basic label printing, like your postal service uses that. Like some of you probably work in web shops, so you've probably integrated some kind of CPL without knowing, I would guess. But we have a library handling all prints for the label printer too, and we included a library called Node Printer for this. I think it's Node Printer. Like there's 2 main libraries for this. So, and it's really easy to work with. If you get some basic function calls like get default printer, and you just get it, and then you can just say get default printer, and then print and send whatever you need to print, and it will do it. It's really simple to do a print, even with raw data like we used. So this is what I was talking about, my example. It's pretty similar to what Søren was talking about. Like our main application, it has it catches all key events, and these are processed by the scanning service, And whenever it receives a valid scan, it sends it out through our state service. Our state service has, in this example, the cutting component is listening for scan states. And whenever that happens, it does its magic. It switches to the correct view state and looks up the product and a lot of different. Oh yeah. So let me show you some code. How are you doing on time? Here. I just have a very simple setup for our app. So our main component, that it uses a host listener to catch all key up events on the document. And this is basically it. You just use the host listener decorator, and then it will pass that event into the function below it. And all these are sent to our scanning service. I'll show you that in a moment. This is just the basic structure. Our state service, this is actually it. So we thought like Redux was a little too complex for what we needed. Our state service is just like a subject, and a subject, for those of you new to Angular, is basically the observable and observer pattern in one. So you get the observable, like we set this here for our public variable states, and then you have your observer we can call from the emit, and all these states are then sent out through the observable. So one cool thing about TypeScript, for those of you new to that, or if you just started, is that you can use generics and advanced types. So you can use your own types if you want to. And this is just a basic example of it. So we only accept states in this service. So how we manage to do this is we have these different state classes. These all have a constructor that takes one argument. The reason it has this is because we turn it into a type called state here. We do this with a union type, and the constructor have to be similar for all the classes, for it to understand that these you can also intersect them. So if you have worked in a programming language with mix-ins, you can use an ampersand to intersect them instead, and then you get more functions. You can include functions across classes. You can see this very simple here. We have created a custom string literal type. It's constrained to either be offline or online, and it's implemented here. So this status can only be one of those two strings. And like I said, you can do a lot of fancy stuff with this. So, and here is like an excerpt of our cutting component. It just uses a type guard here, like an instance of type guard. It only wants the scan stage from this observable stream we get from our state service, and so it filters them out here, and for every state we get, it's just sent down to the scan method on the class. Yeah. So let's see. I have brought the scanning service. This is quite simple, but it handles all our cases. So, like I said, it's basically just the scanner is basically just a keyboard. You receive events from the device, and then, well, you handle it. So every time this receives a key press from app component, we have a timer running that is it's set to 100 milliseconds. So when this timer runs out, it tries to validate the current input to see if it's a valid scan. This timer, every time a key is pressed, it's reset. So within 100 milliseconds after that, if you don't receive another keystroke, it will try and validate. Yeah. So after that, we check that we only want numeric input from our scanner. Some of them will read normal alpha characters too. So, and if it's numeric, we just push the event we receive onto an array of events. And after that, we just call the check scan. It's what, god damn it. The check scan part is what sets this timer. And we use an observable for this too. So we just subscribe to a timer, which means when we want to stop the check again, we just unsubscribe from this timer, and that dereferences the timer. Yeah. So, and checking if this is a valid scan is actually we have a pretty simple rule set for this. Like it's just is it minimum 6 numbers, and what's the average stroke time between received events. So like there's a couple of fields you can type stuff into if you go deeper into the app. And like I said, the scanning service is a global service, so we need to filter out if the user inputs something. Now the scanner is pretty fast at sending these events, and it receives at about 15 to 20 milliseconds. So we just check that the average stroke time for events received is below 25, and that makes a valid scan. If it's valid, we send it out through the state service here. Yeah. I think that's it. Yep. Questions?
Yep.
Yep. Sorry? Okay. We use a file-based database, or a really simple one. We considered that we use AnyDB instead. It was really easy to get going with this, and we had typings for it, and everything was just easy to get going. I would say one thing. Looking back, I would use SQLite. The performance on this thing is not good. So, but we had our goals changed along the way. At the starting point, we only needed to store like 1,000 rows, and this increased when we got started with the project. And with this increase, write times went way up. Like we have, I think one write to the disk at this moment, it takes about 20 seconds or something. And that's because it opens and closes the files between each read and write, and just the writes. So if you want to write 5 times, it opens and closes like 5 times. It's not built for persistence. It's built for in memory.
But actually, if you want to use, I don't know if any of you know the Realm database. They just released it in a final version, I think, today for Node.js. So you can actually use that in your Electron app also if you want to do that. And that's fast, I guess you know that.
Yeah, I think we are going to consider switching to that at some point in this application. Okay. More questions? Yeah.
Talk about legacy for old hardware. Like, what's the memory footprint using Electron? I'm pretty sure people who've been using Slack know what it takes up.
For this app, it doesn't really take up a lot. We don't have a lot of components in our application that I don't know if they have it. There's a lot of data going through Slack, so if they have like one mem leak in that, it's going to be a problem.
They fix some of that problems as well.
Yeah, but it's basically the same as having a Chrome tab running. So so yeah. It's not that bad. Our app runs at like 200 megabytes. So, yeah. You had a question?
Yeah. Did you try the cross-platform part? You said you were only running on Windows.
Well, it was developed on a Mac, so kind of. We didn't deploy any for Macintosh. They're just now trying out Apple products because, well, you know, everybody want to look cool with apps with Apple computers in the stores and stuff. But yeah, so we are trying it out. It takes a little more time to set up the Squirrel thing for Macintosh computers. So yeah. Yeah. Any questions? Okay.